see the settings in the middle of it.
Okay, apologies for that.
You might run in.
We now have audio on the stream. And
Sorry?
Yeah, we now have audio on the stream. So
Okay.
what I'm looking for is from people who actually have 3D printers, and I'll throw Paul into the mix here, because I was hoping Ron would be here, but he supplied me with some things to read out.
Oh, okay.
So
Because
he's sick, so he didn't come up, thank goodness. What I'm looking for is type of printer you use, your experience with the printer, also a little bit around the filament you use and why you use a particular filament for particular applications, software that you use to print, and if you're into designing, the sort of software that you actually use to design and then slice and dice and all of that sort of stuff. And also the main sources of files specifically relating to amateur radio. So we're trying to sort of focus on 3D printing and amateur radio. So, and any hints and tips on 3D printing. So
Take
now,
it away. No?
whoever needs to talk comes up here.
Oh, lovely.
So that we don't have sound problems.
Okay.
Sorry?
That's our talking stick.
Yeah.
So yes,
All right.
this is the talking stick, well and truly.
Well, sure.
So we don't have any complaints
Sure
about
picked a bad day to
audio.
Cocaine.
Thanks, that was instantly demonetised the video that was just mentioned cocaine.
Don't listen to that.
So for those who don't know, this is Paul, VK7ED. So come up, Paul. And also any questions from here or the stream, please shoot them through, and I'll ask the ones from the stream.
Well, yes. I mean, Justin here makes. I mean, I would love for you to be my publicist because you've blown me up far more than I. Because I'm about what, 4 weeks into 3D printing.
Excellent.
Okay, so I certainly anticipated telling a few things, but I have a really good friend who alerted me to a good deal on a printer, and he said they're really going for a good price. So I'd always been interested in 3D printing, and it's a nice little creative hobby. And so what I have is fairly common. It's a Creality, Crealty, and the latest model out latest entry-level model out is an Ender V3 SE. And that model off their website that I saw tonight is about $279, which is a tremendously inexpensive for what it is. And if it's your first time buying it and your first time on their website, it's $264, because that's what I got it for.
There you go.
And I looked around, and the Ender has really good reviews and all that. And the fellow that recommended this to me is a long-time 3D printer enthusiast who's most of his printers, if not all, are handmade or made out of other models. So he's very experienced technically in 3D printing, and so I took him up on that. So it's the Creality Ender V3. You got it up there? Yep. Oh, awesome. And I mean, I wrote down a bunch of statistics on it here, just in case there were people in here that, you know, well, they go, well, what size is the nozzle and how much does it weigh and all that kind of stuff. But you can get all that off the website. I use now the Creality printer comes with its own software, its own slicing software.
Can you explain what slicing software is, like what it does? in simple terms.
I'm looking at my mentor right now, and he's got a big smile on his face, like he can just say 3D, and you're asking him this question.
Okay, I'll ask a different question. Why do you need slicing software?
Okay, this is the best of my memory. You take an idea and you create it in a kind of CAD software. That CAD software then spits out a format of a file, and that file needs to be brought into an application that renders that into a code that your 3D printer understands. And so it goes from Fusion 360 to, I was going to say what I use is Ultimaker Cura. And then that creates a thing, you get an STL file that then gets turned into a G-code file. So the slicer gives the instructions for each layer that gets built up, and lots of other things too. Like if you're creating parts of your printout that the printer cannot print because it's hanging off in the air, you have to create supports and things like that. But I haven't done that yet, so I'm not entirely sure whether, I think that's done back in, I'm not sure where that's done. Len, where is that done?
In the slicer.
In the slicer, okay. So, so there's those three things. So there's Fusion 360, there's your slicer, and then you have to print it. And I was advised to do it a way that maybe not everybody does it. I use, I didn't write that down, that's why I'm going blank. I use, what's it called? Omni? No.
Give me a clue.
No, sorry, the printing software,
That your printer is running
yes.
is Marlin. It's Creality's version of Marlin.
Yeah. I was thinking of the actual print server.
Oh, Octoprint.
Octoprint, yes. I didn't write that down, see?
Okay.
So what you do is you take your G-code file that is the output from your slicer, and you put it into the Octoprint. Now it's like runs off of a Pi, and off of a Raspberry Pi, and it has a web interface, and out it comes. Look, once again, 4 weeks. It's like the difference between an artisanal baker and the guy who pops in that little machine on the countertop. So I can tell you that I use eSun brand filament, PLA Plus, and I'm just trying to think, is there anything else here? The slicer software is that, the CAD is Fusion 360, Octoprint, filament brand is eSun, yeah. And I mean, where do I go to get ham related? I've really only dug into Thingiverse at the moment, and that seems to be a fairly popular. As a matter of fact, for the ADX build, that's where all those files were. And I've printed out the case for the SWR meter.
Yep.
I have yet to have printed out the one for that, and you saw the printout because I gave you the little cases, and that's not so bad. And I think the Creality does. Let me just ask: does anybody here have a Creality? Right. So the resolution's really quite impressive, isn't it?
Depends what you want.
I mean, it depends on what you
I mean,
compare it to, actually, I'm sure, but
It runs on a 0.2 layer,
yeah.
but I mean, you can reduce that layer down so that the quality of print is improved.
I just remember in my head from what I've seen before, it's this rough thing with dags off of it, to look at a washboard surface and all this kind of stuff years
The
ago.
biggest issue is just getting your settings right on.
Yeah.
Depending on the filament that you're printing.
Yep.
Because you can print PLA and then you can go to
PLA-G, yeah.
which is an entirely different type of filament. Well, it's not, but it is
Yeah.
in the print situation. And trying to print it and get it adhered to the bed can be tricky.
Mm-hmm.
Yeah.
I've heard that people use different beds and all these kinds of things.
There are
And
different
and they spray stuff on them or do something like that, you know. Anyway,
And I think
so
Ron's got some things to say about
yeah,
that
yeah,
as
yeah,
well.
yeah,
So,
yeah.
yeah.
So I mean, I'll let go now because you really a question.
Are you taking questions?
Yeah.
I'll take a question. Yeah.
So I'm curious, as someone who's new at 3D printing, what your successes or failures have been and what you've learnt from that.
Oh.
Maybe just repeat the question for the stream.
Oh, sorry. Yes, the question was, as a new 3D print enthusiast, what my successes and failures have been and what I've learned from that. I remembered that. Wow. I haven't had too much in the way of failures. Oh well. The one failure that I've had so far, look, I haven't been like printing every day constantly. It's all I think about. There's other things that are going on. So I'm at a semi-regular pace, but I didn't anticipate a print time. As a matter of fact, the case for the ADX, that's 15 hours.
Wow.
Yeah.
And I thought, oh, I told Justin I was going to print up some of those little Buck Boost cases, and I just started this print.
So you can imagine how long that.
Yeah. Yeah. So
I didn't print. I had that printed for me.
well, that's the size of that radio. The ADX case is this big. By that high. So
That's probably $20 in filament as well.
I mean, a lot of successes that I've had, like it's really interesting. I'm sure that every beginning 3D printing enthusiast does the same thing. I'm looking around for things to print. Oh, what could I do here? So I've got about 6 pairs of off-the-shelf 1x, 2x, 3x specs for working on stuff on my lab. And they're all over the joint. So somebody on Thingiverse had this little thing with these little loops, right? And you could screw it to your workbench edge. And so I've got 3 of those now, you know, things like this. So those are the successes, and it's fun. It's fun going, oh, look at all this mess I've got here. What can I make? You know, so I've got a couple of bottles for alcohol and thinner and things like that are in these little push bottles, you know, little pump tops, but they're sitting there. Somebody's got one out there where there's, you know, you can size them up and put those bottles in there and then put your slot for your glue and all this kind of stuff. Now, as far as radio stuff goes, you know, I'm still looking around. The fun thing is, and I'm sure I'll learn tonight, hence the book, what other people do to find out about, you know, radio 3D projects, you know, ham radio stuff. So,
I have a question.
Can I ask what software you're using to design your programs?
I haven't designed any yet, but it has been recommended that Fusion 360.
Try Tinkercad.
I've heard of Tinkercad as well, but this is what I go on. The person that has recommended this to me is experienced in this, and it's always nice.
Able to offer tuition.
Sorry.
And able to offer tuition.
And able to offer tuition for a limited supply of red wine. But no. But if you have someone on tap who you're a friend with, it doesn't matter whether it's NASA grade if they're going to teach you how to do it. But I have heard of Tinkercad. Matter of fact, that was the other one recommended to me.
It's a fairly straightforward program and fairly easy to get around if
Yep.
you've got no one to talk to.
Yeah.
Which I've learned just off doing what I've done and made mistakes. And
Yeah. It could very well be that I'm a bit too thick for Fusion 360, and that'll be a drop back.
I mean, it's
Back
good.
drop. Yeah.
I would suggest if you stick with it.
Yeah.
Because if you go to Tinkercad and then try and go to the 360,
Oh, yeah.
you'll get lost and you'll.
Oh, well, I'm lost most of the time anyway.
Yeah.
All right. Thank you very much.
Can I just ask, you both had these and you referred to them as being 0.2. Is that 0.2 millimetres?
0.2, yeah.
So that's
Yeah.
the minimum it can...
No,
No, that's,
No.
your print,
that's your layer.
it's
Okay.
just it's a common layer height for quick
Quick print.
and, you know,
But,
where you
but
don't...
you can reduce that so you can get
certainly,
really
you can
fine.
print 1.5 or 1
Right.
quite happily on that machine.
Okay.
I'm happy to talk to any of the points that Paul's alluded to.
Well, I think we
Yeah.
get enough here.
The SE
Come on.
that you've got will go to 3.5 is the maximum height, so your average is around 0.2.
Well, you see,
Depends a lot on the
0.35.
nozzle.
yeah.
Depends a lot on the nozzle size.
I mean, in my opinion, I've thought about it. You know, the Creality for a newbie. I mean, I'm not printing out period specific cosplay masks where you know the whiskers in the wrong spot and you get beaten up or whatever. So or whatever. I mean, we're building functional. We're building functional things for and here's some samples. So yeah.
Okay.
All right.
Probably the reason that printer works particularly well for beginners, I don't know what level people are at, but is that it has a way of measuring true Z height.
Oh,
So
there we
Z
go.
height is the layer thickness height or the height of the nozzle above the print surface.
Yeah.
And it's probably the area where beginners have the most problems.
Len, can I get you to come up here because we'll have some complaints about the sound. Sorry.
Not only is my 3D tutor, he's my public speaking lifeline.
So just to rewind a little bit, how many people are actually active 3D printer owners? There's a few, okay. How many are beginners and
That box
and
that's going around is.
who are the super advanced people who probably, yep, okay. So I'm VK7ED, Len. You probably don't hear me on the air because I'm rarely ever on the air. In fact, that could be a competition, catch Len on the air. But very tricky. I started 3D printing 6 or 7 years ago, and I've been through 2 kit printers, each of which have been through at least 3 iterations of complete rebuilds with modifications to improve them. One of the things they say about buying a kit printer is don't think for a moment that that's it. That's a beginning, that's a starting point. So I could tell you all the story about that, but that's a little bit boring. The reason this was cool to start with is that it has, all printers have a way of probing down to find a fixed point, so a fixed distance, which is a starting point for where you're going to put that first layer of printing. But most of them don't have any way of knowing. It's only a relative measurement that you get from that probing that comes with most printers. You're still left to work out exactly how far your nozzle is above the print surface when you're at 0. So there's all sorts of techniques of taking it down to 0 and then perhaps manually adjusting the bed and using a sheet of A4 paper to slide in between the print nozzle and the bed to find that sweet spot, and then to reflect that in your calibration, so that's where you start from. But if you get that wrong, you might end up printing things that don't adhere to the bed at all, or you end up printing with your nozzle dragging itself around on the bed, carving the first layer into the bed, or into your adhesion layer. So the cool thing with this is it's actually got a little strain gauge on one corner of the bed, and it will run the print nozzle right down until it collides with the bed, and it detects that by noting the change in the reading from the strain gauge. So it can actually find the bed, which most 3D printers in the amateur space don't do.
Is that the one that Paul's got?
That is the one that Paul's got.
Right.
And the reason I suggested it for starting out is that by far and away the thing that most people will go wrong with is getting that initial clearance from the bed. They say for 3D printing, if you can get a good first layer, you're 90% of the way to having a good print, assuming you just followed the instructions, basically. I should point out that we're talking about a kind of 3D printing here called fused filament fabrication, which is melting a plastic filament and sticking it layer by layer. But that's not the only kind of 3D printing. Obviously there's techniques with lasers and metal powders and high-tech stuff, but the other common one you'll find in the amateur space is resin printing, where you have a tank of resin and layer by layer you solidify the resin with an ultraviolet laser. And this can do very detailed things. So people who are into sort of drawing scale model locomotives, for example, want very detailed. They want the rivets and they want the plate joins and things like that. So they quite like to build in resin. But for the stuff we do, fused filament fabrication is the common kind of 3D printing. The material that I use the most is PLA, and I use eSun PLA Plus because it's cheap, it's highly consistent, it's readily available. You can buy it at JCar now, or you can buy it for a lot less if you buy it directly from the Australian distributors like Cubic Technology. There is another one, but Cubic is probably the one I use by default.
3D
And-
Phillies, the other one.
Sorry?
3D Phillies is the other one that I've used. Australian distributor.
For eSun, are they also?
I think they do eSun now as well, yeah. They
Yeah.
do their own as well.
Yeah, so there are lots and lots to choose from. There are big industrial companies like BASF in the space. There's Prusa with their own range of filaments. There's all sorts. But eSun is, I'll tell you a story. I started with thinking, I'll get some cheap PLA filament. So I looked around for the cheapest thing and I got some from this guy. It was absolute rubbish because the diameter was inconsistent. All sorts of parameters about it were just rubbish. And as soon as I changed to the eSun stuff, things improved a lot. So, and PLA Plus is really strong. So it's basic. I forget. It's used in making some carpets and other domestic things. It doesn't give off fumes that will hurt you when you print with it. It's probably one of the strongest filaments it's stronger than ABS. ABS was an early popular one, but you have trouble with layer adhesion and you also have trouble with it warping during printing. You need your printer in a temperature controlled enclosure for ABS. PETG is good. One of the downsides of PLA Plus or PLA is that it has a low glass temperature, which means that above about 60 degrees it starts to move. So if you put your beautiful sculpture that you've designed and printed in the car on a warm day, come back out to the car and you find it's all just melted or sagged. So PETG is a little bit better in that respect. We're jumping around a bit, but yeah. Any questions? Yes,
Do you
Murray.
keep your spare filament, and I'm assuming you have a good stock of different colours,
Yeah.
in a temperature controlled?
No.
No?
No.
You don't worry about any...
It is an issue. Most plastics are hygroscopic, so they'll take up moisture from the environment. If your filament takes up a bunch of moisture, it won't print well. You'll have steam coming out of it as it's melted, and you'll get little popping sounds from your printer and funny artifacts in your print. So I find I've got a house where I've got an upstairs which is always warm and dry. The humidity up there sits at about 40%, even in rain, except maybe in protracted rainy weather. The fire warms it in the winter, and in the summertime it's unbearable without the AC on.
So kind of.
Yeah, so it's but I mean that's as much as it's controlled. So you can pop it in an oven just below the glass point for a couple of hours, and you'll get all the moisture out of it. So if you do have some PLA that I always print something and forget to put the filament away. I try to keep it in the bags with the desiccant, but you forget, and after that 36-hour print, the roll stays on the machine, and just pop it in the oven for a while. Just don't go above the glass temperature, or you'll have a filament, a filament lump.
Inconsistent diameter.
Yeah. Something that doesn't unroll anymore.
Relaxed filament, yeah.
Yeah. Yeah. So on the software, just comment on the software side. If you haven't, most of the things I print now, I draw myself because I just find I constantly need a little, a shim or an enclosure or a panel or thousands. You'd be amazed how many things. An insulator for part of an antenna. And if you can draw these things up yourself in 3D, your printer becomes a real friend in the workshop because it saves so much time. Like if you had to make that thing out of a bit of acrylic that you've got, by the time you drill it and file it and cut it and then snap the acrylic in half and start again and so on, just to be able to draw it quickly is really handy. And Fusion 360, how did I get there? Fusion 360 comes from Autodesk, the same people that do AutoCAD. So it's got a premium lineage as far as design software goes. It's free, which is although you have to dig around on the website to find how to get the free license. But don't give up when you dive in there and it says you have to pay $1,000 a year. It's extremely powerful. It's all parameter driven if you want it to be, but you can also sculpt in there. You can just draw without dimensions if you want to. It works with solids, whereas some 3D design software works with surfaces. So if you think about a cube, you could make it out of a series of planes, or you could think of it as a solid, as a block of wood. And I think because Fusion 360 works with solids, it's a little easier to conceptualize what you're doing with things, because like in the shop, we're working with a solid piece of material. We don't get, a 2x4 plane and put another 2x2 plane along either side of it to make a bit of wood. Lots of videos to help you with anything you want to do. So, if you decide, okay, I want to emboss some letters into this panel to indicate what all these dials do. I can't remember how to do that. Just look up Fusion 360 emboss lettering, and there'll be somebody there that will walk you through it. And I find it easy to use. Just pick your most powerful. It's a web-based app. Pick your most powerful computer and put aside lots of time to learn.
I have a question, if I may.
Yeah.
So this question comes from the fact that you're perhaps at the other end of the scale to where Paul was as a beginner.
Yeah.
And you mentioned at the beginning of your remarks that you've had a couple of printers that you've used them well, they've gone through rebuilds. So as far as an upgrade path and where you find yourself now with these more advanced skills, what sort of a printer are you using now and why?
Okay.
Oh no.
The answer to that, the question is about upgrade paths with printers from a starting point to, in my case, where I am now with printers. So I guess the thing that initially motivates you with an upgrade path is you get a little kit printer sent to you that's been put together in China, and they get better and better all the time. And then you've got printers like this, which are not a kit. This is really a built printer that you just put a couple of screws in and it's ready to go. But if we come back to the kit printers that most of us were starting with a few years ago, they have a lot of shortcomings. And then once you start printing with it a little bit, you notice that, it always has a bit of jitter in it. So your vertical surfaces are not really planar, they're more like wobbly. So you Google around a little bit and you find that somebody says, okay, the bearings that the vertical, that the Z movement runs on are not really true, they rattle around. So you look at how can you modify this printer to eliminate that particular problem. Or you might have an issue with filament not feeding or blocking, that sort of thing. So you start to look at, could I change the print head on this printer to get away from that problem? So that's what sort of motivates these rebuilds. And you can roll some improvements in. It's like anything. It's like a radio, for example, you can roll some improvements in without starting from scratch, but there comes a point where you go, okay, I'm going to salvage the power supply, salvage the box, salvage the coils, and I'm going to do new boards and start again. So that kind of happens.
And how many times have you done that?
Probably about 6 in total. But that's not to say that there weren't useful prints being produced at each of those stages. I guess, where am I now? I've got a printer that started out as a Tivo Black Widow, which is a 400 by 250 print bed. It came with the typical sort of Arduino Mega based processor, noisy stepper motors and all of that sort of thing. It worked, but it had a few of those rattling around problems. It had a massive direct feed extruder that weighed so much that there was massive inertia on the x-axis, so because of the weight of it, and there were much better things than that. So it lives on, and each time I rebuild it, it runs a little bit smoother and quieter. The other thing I've done is move through control boards and printer software. So most printers run printer software. This is the software that executes the instructions to how to print this out of fused filament. So first you design it. You design this thing, which is some kind of a solid, hopefully. Then you feed that solid that you've designed in Fusion 360 into your slicing software, which reduces it to not only a set of layers, but a set of instructions about how to move a print head around to draw these layers in plastic filament, one on top of the other. Then you send that file to the printer, either to a print server like Octoprint, running on a Pi 3 or 4, or you stick it on a thumb drive and carry it over to the printer. And then the printer software takes over, and it's pretty dumb. It just says, okay, move the print head this far to the left and extrude a certain amount of plastic. Now move it slightly forward and slightly to the left and extrude this much. On and on it goes. Thousands of instructions in something called G code. The board that executes that is important, obviously, because of the speed of the processor, its ability to do all of this smoothly and run the machinery in a controlled way. So you can step up from basic boards to aftermarket boards. There's a company called Big Tree Technology that is really big in well-priced, very capable printer control boards. So it wasn't long before I moved from the old Arduino Mega based board to an STM32 based board. And I moved from the RepRap software that my first printer came with to Marlin, which probably most printers come with now, in some flavour. So it might be a proprietary flavour of Marlin. It's open source software, but they make their own modifications to it and build the config files for you. So Marlin is extremely popular and common. But there is an alternative, which is Clipper. Now Clipper does things in a different way to Marlin, and it's a newer approach to 3D printing. Marlin uses a more powerful computer like a Pi to process all those G-code instructions, and then it uses the printer's control board just as an I/O device, really. So instead of expecting that poor little Mega or STM32 to process these G-codes and work out all sorts of things to do with acceleration and motor voltages and all sorts of things, we take off a lot of that processing and do it on the Pi, which is it's unusual to think of the Pi as the powerful computer, but it is compared to these other processors.
Does that speed the print up, taking that off
Does it speed the print up? Yes. And one of the features of Clipper is that not only can it process these instructions much faster, it can incorporate a lot of tuning to tune out harmonics in the printer's operation and basically run your printer at much higher speed. So if you have a printer that you've been faithfully running with a Marlin-based firmware and you are brave enough to try taking it onto Clipper, the honey at the end of the journey is faster printing and getting rid of a lot of those vibration artifacts. You can actually plug an accelerometer into Clipper and run some test oscillations on the printer, and it will work out because we've got rubber belts and things in these printers, and steel and plastic are all springy, they're not rigid. These things move around, so we can measure all those oscillations and harmonics and try and tune them out, and it does it quite well. So I don't know if any of you that have looked closely at 3D prints, but you'll notice near a corner you'll often see a number, I'm talking about a vertical surface here with a vertical corner on it, and as we come away from the corner you'll notice a number of vertical echoes of the corner, if you like. There's vertical lines at increasing spacing as you come away from the corner. These are, in video we call these ringing artifacts, and these are really mechanical ringing artifacts caused by the sudden acceleration of the printhead. So when you get around to doing Clipper, it can tune that stuff out, and it does so quite cleverly. But to make the transition, I'll just point out, so if you're in a world where your configuration for your printer came from the manufacturer, so this is the file that gets compiled when you build the printer's firmware. This is the file that contains information like how many steps of this motor are required to move 1 millimeter, or how many steps of the motor are required to extrude a certain amount of filament. That file, you need to be comfortable with looking at that file before you start changing to Clipper. And it's a plain English file. It's just a plain English config file like you'd find in Linux. But once you can read that file and you have the concept of these parameters, like, there are 13 steps per, that's a ridiculous number, 80 steps per millimeter for this stepper motor to move the printhead. Once you can find those things in the config file, you're sort of ready to start thinking about going over to Clipper. But it's a fun journey. I've done it twice. The first time I decided to go to Clipper because, like lots of people, I had the need for speed, and it sounded great that it was going to be smoother and faster and get rid of the ringing artifacts. And so I configured it, and I got all the, I had the printer was travelling the right distances and things like that, but the prints were absolutely awful. They were just awful, and I could not see what I'd done wrong. So I ditched it and went back to Marlin for a while. And probably, I don't know, within the last year I thought, no, this is ridiculous. It can't be that so many people say Clipper is cool, and it can't be giving results like I saw. So I had another go at it, and this time I got it. I don't know what I did differently. Maybe it was just, I wasn't holding my tongue right the first time.
Suffer right there.
Yeah, we've all been there. But yeah, it's good, and it will work if you get it right. And it has Paul talked about print servers like Octoprint. Octoprint is, well, if you've ever used an HP jet printer print server, when they used to sell the print server as an add-on board, or we used to run it on a NetWare 3 box or something like that.
Stop
Am I that
your
old?
age.
Triggering.
I'm certified on NetWare 3.
I'm certified on GroupWise. I'm getting flashbacks right now.
Yeah. it might be triggering for some people.
Yeah. Sorry, Karen.
Yeah, so Octoprint is a bit like a print server for 3D printing. So it presents a web interface, as Paul said, and you can upload your files to it, and it will transfer them to the printer, and it'll let you have some control of the printer starting a print job and aborting it or monitoring the progress. It also hosts a web camera for you, all of that with a Pi 3 or 4. But if you go over to Clipper, you get that. Clipper needs a web interface as well, but it doesn't use the Octoprint that we use with Marlin. It uses either main sale or a special version of Octoprint. There's an Octoprint Clipper version, but it's a little bit more integrated when you go to Clipper. So I'm probably talking too much about Clipper, but that's just where I'm at the moment. Other materials to print with, so ABS, everyone likes it, they're familiar with it from Lego blocks and 1,000 products that we use. Electronics cases and things like that traditionally use ABS, bits of your car too, but it's a really chemical sort of plastic. It doesn't biodegrade. It emits some yucky fumes when you're printing with it. It needs to be in an enclosure at about 90 degrees while you're printing, and you still have these horrible problems with the corners lifting and things like that. By all means, use it if you need to, but for most stuff, unless we're making it to be in a hot environment like in the car, PLA Plus will work nicely. PETG is good. It's nearly as easy to print with as PLA Plus. PLA Plus would be the easiest. PETG, a little bit harder, but it's not much harder. It has a couple of annoying habits, but you get used to those. So it's definitely worth a try, and it stands heat a little bit better. And the other one that's really fun is TPU or urethane, which is a flexible filament. So you can print things that are a little bit flexible with that. It can drive you around the bend, because if you think about how your printhead works, it's pushing filament into a heated chamber. When you try to push a soft wobbly piece of spaghetti into a hole, it's much harder than pushing something semi-rigid into a hole. So you can imagine that if things aren't right, it buckles up and jams and stuff like that.
Cool.
I think
So you mentioned this is a good one for beginners.
Yeah,
Is
mostly
there-
because of that feature where it can determine the Z height. Yeah.
Is there an upgrade path for something like this? Or is
Could
this
you
set to
modify
get-
it?
Yeah.
It's less so than the kit printers, like the Tivo kit printer that I've got is built with, the 2040 channel and T-nuts and things like that. So you can sort of reimagine it into other things pretty easily. These are more built like a finished goods product.
Yeah.
But there's a thriving market in upgrades. So you just have to look on AliExpress and you'll find enhanced parts that you can fit to your Creality. Yeah.
Just going to add that the Ender 3 line, they use standard aluminium extrusions, so you should be able to get them at most any place that sells you extrusions.
Yeah. Okay.
And modify the structure of the printer.
Yeah. Okay.
Yeah. And there are a lot of printers around that, there are even designs that you can build. Probably, you might have heard of the Prusa printers. Joseph Prusa probably came out with some of the first really functional sort of open frame printers that you could buy as a ready-made thing. They're much more expensive kit than the Chinese ones, but they give really good results. So schools buy them. I'd like to buy one if I had $2,000 to spare. But there's a very good printer that's inspired by the Prusa-like printers from a website that I think is called MakeFR or something like that. It's a French website. They also have a very nice CNC router. So you, like the Prusa printer, you 3D print many of the parts, and there's a couple of parts
So
that
you wouldn't start with that printer?
you definitely could, but you need a friend to
Well,
3D
oh,
print
yes.
the parts for you. Yes,
Oh.
yes.
Yeah, right.
It's like making a lathe without a lathe. It's not easy, but yeah. So that's MakeFR, I think it's called. If you're into building from scratch, but there's lots and lots of others, and there are ones that are built with the slotted aluminium extrusions. If you want to go there. Thanks, guys.
Thank you. Just some comments that have been online. Matt VK7ED just let us know he uses an Ender 3 MaxNeo 3D filaments, PLA and PETG is what he uses. David Somerville, AAE, Alpha Echo. Ender 3 S1 Pro, T-Core PETG, and he uses Fusion 360. And Darrin VK4GEO, who's a regular contributor, Creality CRX, which is perfect for turning perfectly good filament into spaghetti.
They can all do that.
I think Len talked about that. And as such has been in the corner of the shack just over 12 months awaiting a wave of enthusiasm. What I might do is I'll just go on to, Ron, as I said, was going to be here. He did supply a file here, which I'll just go through, and you really can't read that, can you? So his first choice in purchasing was decided by falling into line with what other members of the Flying and Sailing Club, which he's very involved with, used. And that was an artillery Sidewinder X2, which is on the screen. It has a 300 by 300 by 400 mil build volume, a Titan direct drive extruder, a Volcano nozzle, and a 32-bit Ruby control board, featuring automatic bed leveling and color touch screen. Types of filament he uses, the PETG red, PLA white, and PLA ST black. I recommend keeping it simple. Yes, you can go crazy with buying all sorts of weird filament, which I did, but you generally only use them once and then just sit around in the cupboard absorbing water. I did purchase a couple of cheap PLA filaments and it definitely gave me problems with not printing correctly, no matter what I tried. Types of software that he uses, very into creating 3D objects, Onshape and Fusion 360. Both types are similar in use. Onshape is 100% online and free, so you don't download anything. You use it through your browser. Cross-platform, a great advantage is that you can use it anywhere and it's always up to date. It also performs quite well on this aging laptop, showing a mini-kit's case, which I designed one weekend when over in Melbourne. And you can see there's one of the mini-kit filter boards with a, they actually supply the STL file for the cases for them as well. So you can see lovely embossed lettering. Slicing software that he uses is Prusa Slicer. 3D printing resources is Thingiverse. And hints and tips. Okay, he has a couple of hints and tips. I think the most important, which I think Len took up, is to store your filament correctly. You will notice that when you buy filaments, it's vacuum sealed with desiccant. It doesn't take too long for your filaments to start to absorb moisture. Once it gets over a certain percentage of moisture, you start to have problems with printing. And yes, you can buy a filament dryer which holds the whole roll, but they're expensive and you generally have more than one roll of filament. After I've opened my filament and used it, I store it in a resealable plastic bag. Getting rid of as much air and putting desiccant in it. this way all my filaments are ready to go and sit at about 15% relative humidity. You can see there's one in a bag there and all tied up. The sealable bags available from the supermarket. Another very important tip is to keep the printing bed clean, and this goes to your point about getting it to adhere that first layer. I use water and isopropyl alcohol with paper towels. Clean the bed thoroughly prior to use. The following photo shows the printer with a G10 sheet. G10 is a fiberglass reinforced epoxy laminate. A popular choice of 3D printer build surfaces due to its high temperature resistance, dimensional stability, durability and chemical resistance, leading to excellent print adhesion and easy print removal. And you can also see there he's got a surplus mobile phone which he uses as a webcam. The other tip is in the photo is repurposing an old mobile phone, as a webcam to keep an eye on the prints when the printing is being done remotely in the other room or in a garage. It's best to detect a print when that goes wrong and turns to spaghetti early so you don't waste filament. Hope these comments are useful, and I think Ron's actually online as well. So that is from Ron. Who would like to go next?
Okay, look, you go. Oh, okay.
No. Lance?
Rightio. So I've been printing for about 18 months. The printer that I've got is a Flashforge Adventurer 3. If you want to find that one. So what's good about it? It just works, and it just always works. Like you send the print job to it, and it prints, and it looks exactly like what the model suggests.
Not a Kenwood.
It should. Sorry, it's not a Kenwood. So one of the things you're going to notice is once I've gone through the good, I'm going to talk about the bad, which is very different to the Kenwood. There was no bad with the Kenwood. Anyway, back onto the Flashforge Adventurer 3. It just works. It's like. The resolution is an interesting thing. Like
Not available anymore.
No. It's old. It's old and superseded. People like the resolution is fine. Like it prints. Like that was my biggest concern before I started 3D printing. Was what's the resolution going to look like, and is it going to be like it's never going to look like a bought case or whatever. Like it's always going to look like a 3D printed thing, and it only needs to get beyond the point of being, rubbish. They're just so useful without being perfectly flat surfaces. And I would assume that pretty much any printer these days is going to give you, a decent surface. Right, what's not good about this printer? It needs custom G-code. So when we were talking about the different slicers before, like it will only use its own slicer, which is a real pain in the neck. So you can use things like Prusa slicer. What's the slicer you were saying you were using? Cura. Yeah, but you have to find like all the custom parameters. So it's got to execute a bunch of custom G code, and then the heater doesn't work properly, and it's just, So I wouldn't get a printer that doesn't support the standard G code input, which means you can use whatever slicer you want to. The other thing that's sort of that I'm butting my head up against is this poor dimensional accuracy. And so what I mean by that is if I want to print a surface that's got an exact inside space, if my design has an exact space, it's not going to be that space when it prints, right? So there's a bunch of stuff you can do to calibrate the printer, and I've gone through all of that. Where the issue is that on mine at least, when the print head is running like north-south and laying down just like its thinnest line, it's a different width to when it's running south-north. Yeah. If someone can explain what's going on there, all I can think of is that its feed rate isn't quite right, or a slicer issue or whatever. But again, because I can't really use a different slicer. Anyway, so that's a faff.
I used to own a Flashforge that did something similar. Direct feed extruder on this one, I'm not very sure.
It's got a, I don't know what you mean, it's got a tube that comes,
EFT tube and your filament goes straight into meshed
Yeah.
gears that grab and push it down.
Yep.
They slip, and when you're moving in one direction, you
Yeah,
move
okay.
the direction of rotation.
yeah.
Slips in one direction, doesn't
Yeah.
it?
Creality doesn't
So-
take one at the moment.
So this is less of an issue for me going forward, which I'll get to in a bit. Now, but what I should say, so there's this dimensional accuracy, which is a pain in the neck, but there's still heaps of stuff that I do with it, and it's fine. And so with my holes, like I get them too close to what they need to be, and I just have to go on the drill press and drill them out where they need to be. Filament that I use, so I use eSun PLA Plus. Why do I use eSun PLA Plus? Because Ron said use eSun PLA Plus, and we're all talking about our gurus, and Ron is my guru. Hi, Ron. The downside of PLA Plus is it's not UV stable, and so I've printed a bunch of things that live on my portable gear that I take out with me. I also printed some supports for antennas that are up in the air all the time, but after one summer they end up pretty brittle, and if there's much tension on them, they snap. And so I need to experiment with some different filaments. It's just been on the, at some point I'll get there. Yep. Also with filaments, buy black or white as your big spool that you're just going to have, that's going to be your commodity filament, right? So when I bought my big spool of commodity filament, I went, oh, like that turquoise is such a nice colour. I'm going to get a great big spool of beautiful turquoise filament. Everything that I've got is turquoise. Like, man, I just wish it was big and black, but it's not. And so, and I can't waste this filament, so everything's going to be blue for a while. I did make something that's in the shack, and it sort of needed to be somewhere and look quite nice. I ended up spray painting it black afterwards, which wouldn't have been an issue if I had just bought black filament to start with. And, you know, again, sorry Ron, because Ron did say, don't go mad and buy like weird filaments, just get something that you're happy with.
Can I just say, Ron bought rainbow filament.
I think he printed a few things with it, that was it.
So software, I use Fusion 360. I started on Fusion a long time ago using it to model woodworking projects, and so then when I started doing 3D printing, I've just kept going with Fusion 360. For me, like, probably about 80% of the enjoyment of 3D printing is actually the design, and I just really enjoy, like, it's just the first time that I went through this process where you go, I have a need, and so you come up with something in your head, and like 3 hours later you're holding it in your hand. Like, we are living in the future, people. Like, it is amazing. Like, it really is. Like, it just blew my mind. And so I'm at the point now, I'm so familiar with Fusion that I can go to somewhere and download a thing, but unless it's exactly what I need, if I'm going to make some changes to it or whatever, like, it's easier just to make it myself, and it's fun. Like, that's the bit for me that is really fun. What I've learnt, don't try and be really clever with your designs to minimize filament usage. Like, the slices are really clever and they will minimize the filament usage better than what you can. A good example, a while ago I was printing a little case, and there was part of it that needed to be sunk and part that needed to be up in the center. And so I thought, man, I can't have that bit that needs to be up like covering a fair bit of area, because that's a lot of filament. And so I basically made like up, down, up, down. But that ended up using way more filament because it has to have a thick layer on all of those up and down sections, whereas if I just did one great big block of filament, it's not a great big block of filament, it just does that, and then it's just mostly air inside, like it does this beautiful honeycomb things, which when it's thin, you hold it up to the light and you go, oh, like we are living in the future, like it is amazing. The other thing, and Ron alluded to it, is with his camera, that's saved my bacon many times, is you just watch your first layer. Like, once that first layer's gone down, then you can be pretty confident the rest of the print is going to be fine. But I get a bit blasé now, and I don't really bother because it just works. As for if I'm going to download files, I will go to Thingiverse. Prusa has got its own library. I forget what it's called.
Printables.
Yeah, but to be honest, it's probably more like if you go to the SOTA Reflector or the SOTA forums, like they've got a thread on there which is 3D prints for SOTA. And so it doesn't matter where, like some files are on GitHub, some files or whatever. Like sometimes it's more just the topical place where you find these things. So why it's not a problem about the dimensional stability going forward is I need to get a new printer in a couple of months because it's not actually my printer. It's my daughter's work printer, but there was no space at work for it, so she brought it home, and then it was living on our kitchen bench. So I said, "Hey, I've got space in my office. Shall we put it there?" And she said, "Oh, that'd be a great idea, Dad." So
at least it wasn't buyer's regret for the closed garden.
No.
Nature of the software.
Yeah, and anyway, so that's leaving in a couple of months, unfortunately.
Does that mean her work gets commissioned for getting you as a 3D printer?
No. Yeah, and so then it comes to what I'm going to do for a new printer, and I think there's two ways you can go, and one is the route of building up your own printer, and if you really enjoy that, like that's a whole sub hobby. It's just like radio, I think, has got all these subsections of the hobby. I think 3D printing has got that subsection where you enjoy the hardware designing and building and tweaking and whatever else. Like that's not it for me. Like I just want plug and play, where I just want to buy the printer. My enjoyment of the hobby is the designing of the stuff that's going to come out. And so I'm looking at like the Prusas, the Bamboo Labs, those sorts of things. Something where I can buy a kit or buy a made thing, stick it on there, and it's just going to work, and I don't have to tinker with hardware. I'll just be an appliance operator. So. Any questions before we go to the next person?
What was the good thing you used to do the actual designing?
Sorry, what's that?
What was the software that you used
Fusion.
to actually design something?
Yeah, Fusion 360.
Fusion 360.
Yeah.
Now in my understanding is there is a 3D printer on the ISS, and they've been experimenting with printing parts actually up there.
Is that
correct?
Oh,
Oh, okay. There you go. Bamboo Lab, I love it. Now, Lee, I think you had your hand.
Oh, why did I volunteer? Okay. Okay, so was it tariffs? Oh no, sorry, no printers. That's right. I use a Tivo Tarantula Pro. Good luck finding it. There's probably it's a green thing. Tivo, T-E-V-O.
Oh, VO.
T-E-V-O. Tarantula. As in the spider. Pro.
These names are interesting. That pick
It's the green one.
Oh, sorry.
That's alright. That's the standard. Good at images is pretty good. Oh no, that's the one. All 3DP. That's the one. It's probably the best picture they've got of it. That comes up. Okay, that's the one.
Cool.
Yeah. Okay. It's beautiful. Despicable green color. I picked this up secondhand from Facebook Marketplace because I had a Flashforge clone at one stage, which is dual filament extruder. Same problem as you had, where it's fine in one direction, but it's not in the other. And I found it was also very hit and miss with the Z direction as well. The standard 2 semi calibration QB printout was, in my case, was 2x1. I'm just like, pretty sure that's not correct. So what things did it cover? So I find it okay for playing with. It's not amazing. There are some tweaks that, as Len mentioned, that you can tighten up things like the Z-axis on this is not that brilliant. It's very wobbly. So I've actually started to get some stuff to get that tightened up. The software on there is buggy, or can be. One of the interesting things is that it's got a preheat function, but the base preheat function, if you use it without changing the settings, will try and heat the bed to more than the bed can actually take. The bed can take up to 100 degrees Celsius, and default on the software is 110. So you just have to tweak that a bit now and again. Filament I use is mainly PLA, exactly the same as Len said. It's very easy. It's very forgiving. I would have occasional warping with it, but very, very rarely. It's only because the bed didn't heat up properly. The one problem with these is that if the fan turns on halfway through a job, rather than slowly ramping the fan up, then the head will suddenly go into thermal runaway. So it's like, again, it's a bug with the software. I'm still running on all the original Arduino based stuff, the Maker ass board that came with it. But overall, I find it does a really good job of stuff I need. I printed a few like brackets and things for antennas and that sort of thing, and it worked quite well. Even outside, they seem to hold up quite well. I've also played with PETG. PETG is a bit less forgiving on this printer. You really got to just sit there and play with the settings. But I've managed to get some prints out with it. I'd echo what Lance said about making sure you don't buy weird colours. I bought a roll of bright green filament. Never again. Sorry, not bright green, bright gold. Sorry, it was quite gold. It was cheap at the time. Yeah, no, don't do it. That was PLA plus. PLA plus I use because, again, it's a little bit more. Again, go back to what Len said. It's a little bit more forgiving. It's a little bit stronger, and I actually find it easier to print with than PLA. I'm going to get my stuff again from Cubic. Though I had bought 3D Phillies from 3D Phillies before, but I'm not sure if they still do. That filament, I can't remember. I used the. Sorry, what was the filament you said? I can't remember the name, but.
eSun.
eSun, yeah, I use eSun filament as well.
Cubic have got heaps of other brands.
Yeah, they do.
Cubic, and it's very hard to beat their prices.
Yeah, and eSun is actually quite a very, very consistent filament.
It's great
brand.
Yeah, for the price, it's brilliant.
One of the best I've used actually, and also the colours are also quite consistent as well.
Yeah.
Some I've used are not that consistent. So you end up with some and you go, oh, I've run out of green. Okay, I'll use the next roll, and you end up with a lighter shade of green. No, it's all the same colour. And in terms of my experience level, I'm probably low to medium. I've been doing it for about, I'd say, with the Flashforge clone I had, I spent probably about a year or so playing with that, and before I sold it on to some other I mean some other enthusiast. Sorry, enthusiast. Yeah, that's the one. And I agree with Lance that we're now living in the future. I can go, I want something, and then I want this piece of plastic that will fix onto my antenna. And I print it out, and it's this little thing about that big, and in 72 hours I can come back and I've got it in my hand.
72 hours.
I'm sorry, I'm exaggerating. It's more like 96. But yes, you can print this thing out and actually get it working. Oh look, postage isn't that bad. I'm looking at actually, Len's inspired me to actually look at what I can do to upgrade this thing, because actually rebuild it. Because it's more or less a kit printer, you can actually take it apart a bit and do some stuff with it. The step motors are noisy, the drivers aren't that good, that sort of thing. So I'm looking at upgrading it. But again, there comes a limit when you go, okay, I've actually got to go and get a new printer. And the printers that have come out since this one was released a few years ago have taken it another level. So I'd echo what others have said about the Creality. They seem to be a very solid printer. Prusa's are amazing, but they are expensive. And the Creality, and I think you've even got the multicolored attachment as well, so you can actually have a filament box.
Multiple filaments.
Yeah, so you show a filament box. It's about $500 US, I think, and the box sits on top of the printer or somewhere near the printer, and it switches the filament for you automatically. So you can print in multicolour.
I think even Joseph Prusa nearly went mad trying to get that to work correctly.
Yeah,
So
but they seem to have got it almost.
I haven't been brave enough to dive into that.
Me neither, but I looked at it, and the reviews say that it seems to be reasonably flawless. I still would prefer to do a dual filament extruder if I'm going to do that. The other thing I mentioned that amazed me, which came out a few years ago, was that you can now get water-soluble filament. So if you've got a dual extruder printer, you can print the support material in this water-soluble, and the shape
drop
you
it
want.
into a bucket of water and it disappears.
Yeah, and so basically you get these amazing spiral or shapes that you could, be very difficult to print without without that option.
Very difficult to extract the supports.
Yes, exactly right. And so you've got these almost these floating.
Oh, you have blind supports.
Sorry.
Blind supports. I mean, supports in areas that you couldn't even get to.
Yeah, that's right. And you can just chuck in a bucket of water and leave it for half an hour and it dissolves. So again, there's a lot of stuff out there that most of us wouldn't get into, but I'm one of these people that says, "What can I do?" And I get very excited about it. And that's me. Any questions?
What build surface do you use?
I'm using the one that came with it, which is basically the
PEI.
Sorry.
Is it PEI?
It's PEI. Yeah, I am looking at changing that to getting some borosilicate glass and putting that on top instead. Only because I find PEI is great if all is equal, but adhesion can be a slight problem with that surface now and again. I tend to use recommendation from Ron was to use glue stick.
Yeah.
Which I now use.
Blue painter's tape.
Yeah, I've used blue paint.
Solution of aqua here.
Yeah. Well, I mean, I don't use hairspray because there's no other point.
It's really hard. There's only one hairspray, which is an American product that you cannot buy here, that people have really tested and found to be good for PLA adhesion.
Yeah, we can't afford it anymore.
And the closest thing anyone's come up with here is a particular Seidel hairspray from the 80s.
Oh, wow.
Which is horrifically scented. It's like you can smell it a block away, and it really doesn't work as well as it should.
But yeah, I use a glue stick, and the great thing with that glue stick is it's water soluble. So every now and again, you just get a damp cloth and wipe the bed off, and then start again. And it's cheap. I mean, you can buy it. What's like $3 or $4 for a couple of sticks of that stuff, and it lasts. I'm still on the second glue stick now, and I've printed loads of stuff. So it's very cheap.
Cool.
Oh, software I use Prusa Slicer because it handles that printer quite well, and I use Fusion 360.
Okay. We're getting a theme here.
Yeah.
Who's next? Come on, Praj.
I've actually got show and tell.
You need to come up here for the sound.
And if you wouldn't mind, just introduce yourself.
Yes, only some of you. I've only met some of you. My name is Praj. Live up in Brisbane. Just recently applied to be a club member because we're moving down to Hobart soon anyway. So I got a VK7 call sign beforehand. Some of you, if you've been hunting me and Kiri, we've been activating a few parks. VK7 Mike Papa Bravo. Yeah. Anyway, I've been 3D printing, since when the dinosaurs roamed the earth. Back when you actually cobbled together your own stepper motors and sent in code through. Painful, but I agree with the Flashforges having that issue. I used to own a Creator Pro, and they've got that slippage that happens every single time, and they don't seem to have fixed it. I've been 3D printing in filament for a long time, but about 6 years ago I started printing resin as well. So I've got a lot of printers.
This is going to be challenging. Challenge accepted.
The one that I've most recently broken is the AnkerMake M5. It was a Kickstarter thing that everyone hated because they ran a closed software, not an open source one. Everyone sold off, and then Anker went and made it compatible with Cura. So it's beautiful, works with everything now. If you can get one on the second-hand market, I would very strongly recommend it. Fairly inexpensive, very fast.
But you broke it.
Oh, I broke it. I broke it doing something rather silly.
Break, or you just worked it hard?
So that took about an hour 10.
Wow.
And the fun bit, that's TPU.
Yeah.
Oh, wow.
So when I'm actually out and about soda potter, I can throw this around, it's not going to break. And dimensional accuracy is spectacular. Didn't need much fiddling. BNC connector sort of fit on straight away. Holes are fairly uniform. And that's with minimum tinkering of the software. It's they've used some fairly high quality belts in that. They sold it for a price that's way lower than what the manufacturing cost is. They don't make it anymore.
So yeah.
Yeah. So you can only get that on the second-hand market, but if you can get one, most people who don't know that Cura is not compatible with it, just get one. It costs about $300, $350 on the second-hand market if you can get one. The other advantage of that, this is what I was talking about in terms of aluminium extrusions, is it uses standard fittings. I had an issue with the Z-axis vibrating. Drilled out the hole a bit deeper, put a bigger bolt in, done. Easy as that. One of my X-axis motors down there, the belts had an issue. Drill an extra hole in, tighten it up, just yank the belt tighter, fixed. Because it's using standard extrusions, it's really easy to fix anything that goes wrong with that printer. And my absolute favorite thing is it's got 49-point leveling.
Oh wow.
Which is just glorious. You push a button. I've used the Flashforges, which have that weird 3-bolt leveling technique, which is just not pleasant at all.
Yeah.
I used to have a Creator Pro till about 2 years ago, and I gave it away because no one was willing to buy it. It's a dual extruder. It's awesome. I used to do the water-soluble supports inside, but nah. But it also comes with a magnetic print bed. So it's a steel plate that's got texture in it. And this is the first print bed that I haven't had to use Kapton tape on. It just adheres. ABS, not so much. PLA, beautifully. And it leaves you with a very pretty texture. Feel free to pass that around. That's the texture of the print bed.
Can we have a look at the other one as well?
Yeah, sure.
What is the material of the print bed?
Steel.
So
Steel.
steel's of it.
Yeah.
Wow.
So you've got heat transfer coming through beautifully.
Yeah.
And because it's these really flexible spring steel plates,
Yeah, that's nice,
you just peel one off, slap the next one on, and off you go with your printing while you get the supports off. And taking something off the print bed is a simple matter of just bend your print bed, it pops off. And well, the biggest issue with that is it's not available. But they make a cheaper version of that called the C2. Still uses the same mechanical parts, still compatible with Cura, and it's available at the moment. So it's not as fast as the M5, but it does the job. Is it the C2 or the C5? Something else that's happened with this company is it's just been bought out by Eufy, the guys who make the robot vacuums. Anker sold them over to Eufy. Eufy's just promised to resurrect the M5 line, so it might come back. We never know. In terms of filaments, so there's PLA and TPU going around. There's a bit of ABS. The way I got ABS to work was I put it in a grow tent. So I took the entire printer, you know, one of those foil-lined grow tents that you get, zip it up, and that keeps the heat in. So you preheat the print bed, wait about 30 minutes, trap the heat in there, then start your print. And ABS prints well, but it uses a lot of power, so I don't print ABS too much. I really started to like TPU because it's tough, it's UV stable, it's not as hard as nylon, you don't have to get up to 200 degrees to print it. And super lightweight. I got the weird colors because that's mostly used in parks and summits, and I like to be able to see where the parts are. But in terms of more practical things, that's K6ARK's little mic build. 3D printed and heat shrunk, basically. That's PLA, it does the job. And the cool thing is, as you were saying, Lance, and you were also saying with Fusion 360, you can adapt any model to work any way you want. I play around with Tinkercad a bit, but Fusion 360 is great. And what you can do with that is 3D print yourself a little CW key. That's just got a pair of standard momentary buttons inside. Nothing else. It's just the plastic being its own springiness. Same cable, plug it in at the other end, and you've got an Iambic CW pedal.
Wow.
So that's the mic. 3D printing is fantastic in radio. I've just been loving it. I'm part of the Brisbane Amateur Radio Club up there, and in terms of a few more show and tell. Oh, talking of PLA and temperature stability, I brought a failed one along.
Yeah.
So there's a reel that I built up going, oh yes, I can take this along and string out my antennas. Hung it out in the sun for a day. You can see how it's warped, and I still need to pull the toroid out of it.
And what was that made of?
PLA. PLA Plus. The exact same thing. This is why I love TPU. Nice and flexible. Actually lighter than that. I've got a FT240 in there, the toroid. And I can actually throw it across the room and know the toroid's not going to shatter because the print takes the bounce out of it. Yeah, it's, if you can get the printer working with TPU, which I know the M5 can, it was really easy. Just I used the values that were on the forum with the title that said, how do I print in TPU on this thing? And I went, right, punch those numbers in, and it worked. I've tried printing in TPU many times before this. Wouldn't work, but it works with this one.
Is it a Bowden extruder or direct feed?
Direct feed.
Yeah, I just couldn't tell from the picture. It looked almost like it had a Bowden kit.
No, it's direct feed.
Sorry, if it's not direct feed, what's the other alternative?
Bowden, which is where you're pushing the filament through a tube, basically like a Bowden cable.
Okay.
Like the choke cable in your old car.
Yeah.
But I think with TPU, a direct feed extruder is almost essential.
Yes.
Yeah.
Because it's just too stretchy otherwise. The minute you start heating it up, it turns into a rubber band. One thing I would recommend if you're looking at getting something like that, an open bed printer unlike the Adventurer, is find some sort of cage for it that'll keep it warm. It can be a grow tent, it can be an acrylic case. It can just be an old aquarium that's been sitting around that you drop it into upside down. It'll do the job. Because thermal stability is super important. Which brings me to something I don't have show and tell of, but feel free to pass that around. Resin printing. If anyone's played around with resin, you can make far more complex shapes than you can with filament. I've been printing resin for a while for work. We take CT scans, turn them into 3D models, and then print that model. Which means when students, undergrads, slice that 3D printed skull open, the inside looks like what a real skull would look like. It's something that I've just started playing around with for radio, because I do a lot of other stuff, making miniatures and painting them and things like that. But the resolution's phenomenal. Dimensional accuracy is at the micron level. So if you're building anything out of resin, it will work. It will not survive being left outside, but the solution to that's really easy. Spray can of varnish.
Is there any health issues
Don't
with resin?
don't print in your house.
Don't put it what?
Don't print in the house, print in the garage, print outside.
Yeah.
Be aware that people can develop reactions to the toxins in the resin. Not particularly toxic, don't drink it. I've had spills on my hand, it's all good. But I know people who can't, they'll react to the smell of the thing. So outdoors is best, or garage. Once again, temperature control. I use one of the beer brewing bands around the vat. Keep it at 28 degrees no matter what. And prints turn out picture perfect every time.
With the resin, do you use a rinser then afterwards to clean it off, or do you use?
You can, I tend to use water-soluble resins.
Yeah.
But the ones I use at work are IPA soluble. I would recommend isopropyl alcohol to water. Water gets messy, it doesn't dry up quickly enough. I then have to hold a hairdryer over it. But I don't want 40 litres of IPA at home.
No.
So it's the work one that's got the IPA. The work resin printer's about that big.
Yeah.
So it prints an entire hippo skull at size. It's got a skull that big that's come out of it.
Wow.
But the quality of the print is phenomenal, and if any of you like to play around with metalwork, something that I've found you can do is cast it in plaster of Paris, cast your resin print, then just heat it with a hairdryer, the resin flows out, it melts and flows out. Pour aluminium in, you've got whatever you've got. My former manager makes some little steam engines with that method.
Wow.
So it does a great job. You can use water-soluble resins for that. There are actual water-soluble resins, but the environmental side effects of that are just far too many, so I prefer not to use a water-soluble one. Now coming to how I broke my AnkerMake M5, as fellow amateurs, you guys will love this. PLA Plus comes with metal fragments embedded in it. So you can get versions of PLA that have copper in them, that have bronze in them. You can send electricity through the print.
Does it have some sort of metal in it by default, or do you?
No, this is just, you get specific ones.
Okay, yeah.
So I've been playing around with trying to 3D print an actual antenna.
Oh wow.
And unfortunately, I forgot that my hot end was not all metal.
No.
So I've got an all metal hot end now, I just need to swap it out. I just melted the entire thing. I'll post a photo on Discord with what it looks like. The entire thing's just a lump of black and gold there. But I've got the all metal hot end, I just need to find time to swap it out.
So what's the melt temp then of these particular?
Melt temperature isn't particularly high, it's PLA plus again. You're working with really fine, it's almost dust, metal dust embedded.
Also the conductivity.
Conductivity is spectacular. I've lit up LEDs with that thing going hot. Resistance on a, so printing something about this big with LEDs in there and a standard 9-volt connected across it, barely gets warm. I haven't actually measured resistance in any sort of scientific way, because I've been playing around with it for the most part. But one of these days I'll actually have to get around to that. So this was why I wanted to 3D print an antenna, a 70 centimeter antenna, and see how that would work. Turns out I blew my hot end. I'll replace it, I'll get some photos up once I actually get that going. But you can print in copper, you can print in bronze, you can print in steel. And because you're melting the plastic, but the metal's not melting, just make sure you run an all metal hot end. This will work with any printer that's capable of pushing PLA through, because melt temperature is that of PLA.
So if you've got like a volcano hot end, it should be fine, the metal extruder as well. So
Anker, before they stopped making that printer, actually made a full all metal head for the printer. So that's what I've got my hands on.
Yeah.
Someone had one, didn't want it. Said they'll sell it to me for postage. Sure, I'll take it.
Oh, if you insist, yes.
Well, they'd sold their printer, they just had this hot end. I'll take it. So it's sitting at home, I haven't fitted it up yet. But yeah, it's a brilliant thing. Someone was talking about rainbow filament.
Wrong.
Oh yeah, I love rainbow filament. So here's, where are we? Sorry, lots of things in here. I also do a bit of aircraft tracking at home. You basically stick a SO239 in there, face down, comes out of the bottom, bolts in, solder a copper wire to the top, goes through the top of that, you've got your radials coming out. Bend it, that's actually chamfered to 45 degrees. So you just bend it down, that's 45 degrees. I've got one of these sitting on top of a little PVC tube on the rooftop. Where in Brisbane, I'm picking up aircraft in Grafton. Does the job.
Wow.
So,
Cool.
yeah, it looks pretty.
Wow.
It just doesn't work with everything, but it looks pretty. And Kiri's got some piano students who come over, little boys, and we've got 3D printed dragons for them to play with. Rainbow dragons. Couldn't get cooler than that. Yeah, they love that.
Wow.
In terms of software, I use Tinkercad for the most part. Super easy to use, it's online. Fusion 360 for the bigger projects, but Tinkercad just lets you, it's really simple to build shapes and intersect shapes and get whatever you want. It's also what I use to teach people how to 3D model. It's got a fairly simple set of mechanics, for the lack of a better term. I grew up in the SolidWorks era and had to play around with SolidWorks at uni, and yeah, Tinkercad's so much better after that. That'd about be it.
Cool.
Yeah, I've got a few more bits and bobs here. These are the things I've actually just been deploying on Manfield. So 3D printed bits and bobs, if anyone wants to take a look at them.
Yeah.
Yep. Got them here.
Which summits did you do on Mountfield?
East. Yeah. No, the so you know the pole toppers that people 3D print, the simple one. It comes off whenever your pole flexes. Solution to that: print it in TPU, and you friction fit it. Because it stretches as you go down.
Stretches.
Oh wow!
Do you need that, Jim?
Jim's at the top of a very deep rabbit hole.
So
looking down.
apparently I'm on the limit of, I own 11 radios, I'm on the limit of number maximum radios I'm allowed to bring into the house. We haven't started on 3D printers.
Printers are N+1 as well.
And just simple practical things like that's what I use to stick my HD up on the desk. Just clip it on and you're done. You don't have to worry about anything else. And that can be modified pretty easily, and you can resize it to whatever HD you've got, and it just works. And when you've got a printer that's fast, this was about 1 hour 30.
Wow.
And fast and modifiable, so it just does the job. If anyone's looking for a cheap, fast printer that kinda gets the job done almost, Elegoo makes one called the Neptune 5. It's about 150 to 170 US when Amazon puts it on sale, which they do about 3 or 4 times a year. Great printer. Elegoo, Elegoo, E-L-E-G-O-O. Neptune.
That price you can have 3 in the house.
Yep. Elegoo and Creality seem to sort of either have the same people doing the design or one is stealing designs off the other. I have no idea what's happening there. I'm not going to get into the politics. But Elegoo gives you the cheaper version of Creality, and it works. Their resin printers are fantastic. And the school I teach at has a Bamboo Labs X1 and a Neptune 4, including the multicolor filament feed through.
Yeah.
Works beautifully. Anyway, thanks guys.
Thank you very much.
And there's another piece that fell.
I'll grab that in there.
Okay, anybody else? I haven't had any more from the group. We've got 17 watching right at the moment, which is fantastic.
17. Is that a record?
That's a good number.
There's lots of interest. That's what it's about. So
So in saying that, a really good question for those potentially wanting to look at going down the path of 3D printing as a beginner, what advice would you give them?
don't do it. Don't do it.
I'd start with that.
Don't drink the Kool-Aid, don't do it.
Don't go into the
But then he brings all these toys.
Sorry, it's like the Monty Python sketch. Run away! Run away!
Oh. If you do, start with one of the Elegoo line of printers because they're cheap. If they break, their parts are easy to get, easy to replace.
Yep.
And their support actually works.
Yep.
I've had massive print screens fail and call them up, and a week later I've got the screens.
Yep. Yep.
Shipping's not too expensive. They're available on Amazon. They go on sale.
Yep.
So you don't end up burning through a lot of money if you.
Yeah, the
go
Elegoo
in
one I
and
just
go-
found on their website.
Yeah.
So
Yeah.
You might just, after playing around with it for a year, go, I don't want to have anything to do with this.
Yeah.
At that point, you don't want to have spent a couple of $1,000s on something.
Yep.
As opposed to maybe about 500 or 600. eSun filaments are great.
Yep.
But this is eSun TPU, all the PLA is eSun stuff.
Yep.
Does the job. They go on sale. I'd say get
eSun's the flexible one, yeah?
no, even the PLA.
Oh, okay.
Everything's. I only use eSun because they go on sale often enough for me to bulk buy.
Right, okay.
And Bunnings sells these really nice watertight boxes that
Yep.
you can just drop your filaments into and put a desiccant in and close the lid and
Yep.
fairly, yeah, keeps it fairly dry.
Give it 25. Give it $25. Got one
Yep.
recently. Alright. I can also say how you get
Cool.
cheap gas.
Murray.
I just really want to expand on your advice of don't. I think 3D printing is amazing for amateur radio stuff, and Justin's got some pictures there of our field day van and some many brackets that we've printed for that, both inside the van to hold radios, outside the van to hold antennas, brackets that stack the antennas when they're down, brackets that hold balance, AV balance underneath antennas, all sorts of things. But there's an easy way to do this 3D printing that none of you have spoken about tonight.
Yeah, we know what it is.
It's called 3D printing as a service. You have a friend who's really into this stuff, and I'm really serious. Like, Ken has printed all this stuff for us, and like his, and I don't know how many printers Ken's had. These all come off his 5-head Prusa XL, which he has a custom made thing to keep it at the right temperature, and it's got a heater in it and all the rest of it. It looks all way too complicated to me, but at the end of the day, you rock up there, he gets SCAD out, he types a whole heap of stuff onto the screen, which makes no sense to me. And then it brings up a picture and he goes, is that about it? I'm like, yeah, let's give that a try. 14 beta versions later, we end up with one that actually fits. I don't know what PLA we use. I don't know the difference between PLA and PLA Plus. I just buy the stuff at JCar and give it to Ken. So whatever they have is whatever we use. But what I was going to say is, this is all PLA, and this stays outside year on, year out, and we never have any issue with it.
You're in Hobart, I'm in Brisbane.
Look, there is that, but I was listening to what you said about that. I looked at the thing you sent around, and it actually dawned on me that maybe the white, because we did particularly go for white because it was going to be outside and reflect as much heat rather than absorb as much. So I'm like, when you said that, I'm like, maybe that was actually a really good choice of white. Like,
the colour makes a big difference.
Yeah, yeah.
And some paint pillars as well, some silver or white paint.
Yeah, and they've been particularly strong. The only time we've broken them is when we've actually had one end of the antennas tied to the bracket that they sit on when we accidentally put the mast up. And that was a big oops. We had to, yeah. But so, as far as our radio brackets go, all our radio brackets inside the van are 3D printed, where everything just sits in 3D printed galore.
And Murray, your 3D printing as a service, can I just say, there is 3D printing as a service.
Yes, you can actually do it online. You don't have to have a friend, you can.
The 705 case that I showed earlier was a Thingiverse print file that I sent to a 3D printing service. I could not believe what I could get it printed in, and me going, I don't know any of this. So quick Google, pick the colour, and I did the colour exactly the same. It's bright orange, purely because if I drop it somewhere,
it's easy to see.
I need to see it.
That's really good if you know exactly what you want. But when you're doing stuff and you think you know what you want,
is prototyping.
and then you take it home and then you go, oh, this doesn't fit that bracket. This element fouls with that. We need a little bit out of here. You mark it up with a text, or you take it back to Ken. So these are all. You've moved on.
But that's
VK7 KOJ or VK5 KN, whatever it calls those going by on the day. Has printed those all, and I just spotted a picture of some of his other handiwork down the back on the inside of our van there on that picture. So yeah, for amateur radio, it's the most amazing thing I've ever come across. It just makes, like, what would take us days and days to manufacture out of aluminium and cut and
mill it up and whatever we have to do.
yeah,
Just
yeah. And okay, we have to wait sometimes. You know, this big bracket here took like, you know, I had to go back the next day for this.
Yeah.
Well, all right. All right, that's all I got to say.
fantastic, Murray. That's it.
All right. Any final points before we wrap up?
Just
right.
to add one final point to prototyping, you probably already have them, but for the others, vernier calipers, your best friend.
Yeah.
You want to-
So vernier cut for our streaming viewers, vernier calipers are your friend if you're prototyping, well and truly. And in fact, I have 3 or 4 sets of them in the workshop. It's the go-to measuring device. Fantastic. All right. Thanks for everybody's input. I hope you've learnt at least something and worked out whether you want to go into that rabbit hole or not. So yeah, thanks very much. Cheers.
Cheers.
out there.